Hello class 11, we are dealing with friction and the topic that we are going to discuss today in this video is angle of friction. Now let us see what this is. Say we have a tabletop on which we have a body placed, could be a book or could be a duster, could be some kind of a box whose weight is mg, m being its mass, r the normal reaction. Now there is an external force acting on this body. The external force I haven't shown in the picture of course, but there is an external force acting because of which the body is on the verge of movement, not yet moving mind you, it is on the verge of movement, because of which there is a force of limiting friction, the maximum value of static friction mind you, acting on the body. Now of course the limiting friction is acting here between the two surfaces, but what I have done is, since force is a vector, I have shown that limiting friction or maximum value of static friction over here. This is acting in this direction. So Fs is that limiting friction. Now since the body is on the verge of movement, therefore Fs is the limiting friction, mind you. Now there are two forces, the normal reaction and the limiting friction. These are two forces, as you can see, starting from the same point. So what we can do is, we can draw an imaginary parallelogram. We will complete our parallelogram first. Then what we can do is, we can draw a diagonal starting from the same point, mind you. And this diagonal starting from the same point is what gives us the resultant between the normal reaction R and the limiting friction F of S. Okay, so let us call this reaction, what do I call it? Not reaction, let us call this resultant. Resultant is what? Say T. T is the resultant vector. Alright, so vector T, so to say, is force of limiting friction plus the resultant. This is a vector equation, mind you. And the magnitude, of course, of this vector is given by the magnitude of the resultant in case of parallelogram rule, square root of a squared plus b squared plus 2ab cos theta minus 2. So the angle between this T and the normal reaction, let us call that theta. Now this theta is what is called here angle of friction, mind you. Okay, so therefore how do I define it? Therefore the angle of friction is the angle which the resultant of the limiting friction and the normal reaction makes with the normal reaction itself. Okay, so therefore the angle theta which the resultant T in our case, mind you, with the resultant T of the limiting friction and the normal reaction R. So T is the resultant of the limiting friction and the normal reaction makes with the normal reaction is called the angle of friction. Now from this picture we also see that the tan of the angle of friction is equal to F of S divided by R, because if this is F of S, this vector also is F of S, so tan theta is perpendicular by base, so F of S upon R. But we also know that the coefficient of static friction is equal to Fs upon R. We've done this already. So if this is equation 1, this is equation 2, therefore from equations 1 and 2 we get, let me erase this definition, I hope you've copied this. Therefore from equations 1 and 2 what we can write is the coefficient of static friction is equal to the tangent of the angle of friction. Sometimes you get a 2 marks question asking you to find the relation between coefficient of static friction and the angle of friction. So this will be that relation. Let us now discuss what is angle of repose. Now before we jump into the definition, let us pay attention to this picture over here. So we have this incline, and on this incline we have a body whose weight is mg. Now the body is not sliding down the incline yet. Now what we do is we gradually, very gradually go on increasing the incline, that is the angle of inclination. Now there will come a point when the body will start sliding down on its own. Okay, so therefore the value of the angle of inclination at which point the body is not sliding but is on the verge of sliding down, just about to slide down the incline, okay, that value of the angle of inclination is what is called the angle of repose. So thereby the maximum value of the angle of inclination at which point the body is on the verge of sliding down due to its own weight, without we applying an external force to push it down. Okay, so it starts sliding down on its own is what is called angle of repose. Now again, let's come back to the picture. Mg is its weight, R is the normal reaction. Now you can see the normal reaction R is not opposite to the weight of the body, because the normal reaction always has to be perpendicular to the surface. Remember, it always needs to be perpendicular or normal to the surface. So therefore R is in this direction, not opposite to the weight. Let me draw this line over here. Okay, if this angle is theta, then this angle will also be theta. You can find that out. Okay, so mg therefore can be resolved into two mutually perpendicular components, one along this direction and the other along this direction. So if this value is theta, this one will be mg sine, this will be mg cos theta, and this one will be mg sine theta. Now you need to understand this. The normal reaction R is equal and opposite to this component mg cos theta of the weight, and it is because of this mg sine theta component of the weight that the body starts falling down or sliding down the incline if we increase the value of angle of inclination beyond the value of angle of repose. Alright, so this is resolving mg into two mutually perpendicular components, as you can see. Now if you are wondering how this angle is theta, okay, let me show this to you for the first and the last time. Say I drop, this is a vertical. So if this is theta, this angle is 90 degrees, alright, and this angle will be how much in this triangle, so to say. This angle will be 90 degrees minus theta. So if this angle is 90 degrees minus theta, then this incline and this line mg cos theta, representing mg cos theta, they are perpendicular to each other. Okay, so therefore if this angle is 90 minus theta, then this angle has to be theta. Try to do this yourself. Okay, so the body is on the verge of sliding down, as we were saying, since theta is the angle of repose. So to say, the body wants to slide down, but something is preventing it from sliding down. What is that something? That is the force of static friction, or so to say, that is the limiting friction. So what we have is the limiting friction is balanced by mg sine theta, or so to say mg sine theta is balanced by the limiting friction, because of which the body is not sliding down. And likewise we know R is mg cos theta, as we can see from the picture. So this is my equation 1, this is my equation 2. Dividing equation 1 by 2, we get, what do we get? F of s upon R is equal to mg, they divide each other, sin theta upon cos theta becomes tan theta. Okay, but Fs upon R, what is this Fs upon R? Fs upon R is your coefficient of static friction. Alright, so therefore this also is, so to say, another relation between the angle of repose and the coefficient of friction. You also get to derive this equation or relation, so to say, sometimes. In case of an inclined plane or a body placed on an inclined plane, the angle of repose and the angle of friction, so to say, are one and the same, mind you.